So what we're looking at here is a 6-week trend graph, right? That shows some pretty steep looking lines. Now, if you recall in the last video, I talked about how short-term trends can have steep fluctuations, right? So this is just an example of a short-term trend with steep fluctuations. So because you can see over this 6-week period, these these numbers fluctuate so much, it's not appropriate to use a regression analysis. So here, therefore, we're going to use a moving trend analysis, right? A moving average analysis. Okay. So in order to do the moving average, you're going to start out with something that looks like this, right? So I set up my data right here, where I have my week, my day, then my day number, and then my revenues, right? Which is Y. And so you can see my week 1, week 2, 3, 4, 5, and 6. And then I have my days labeled Monday, Tuesday, Wednesday, Thursday, Friday. And this is a work week, so Monday, Tuesday, Wednesday, Thursday, Friday. And if you recall back to the prior video, I have an example, or rather in the lesson slides, I have an example that gives a scenario of why we're using 5 days over 6 weeks. Well, we're doing a 5 day moving trend. And then my numbers are here. Day number 1 through 30, so I'm dealing with 30 days. And then my revenues that I collected on each day are here, okay? And this is represented by Y. So just to kind of keep this brief, I'm going to show you the completed moving average, right? And you have access to the spreadsheet, so you can anytime open this up and look at my calculations, or you can just copy it and paste it into your own sheet and use it at your leisure. So here I have my sum, right, for my 5 days, okay? And then I have my average over those 5 days, right? So my average for my first 5 day trend is 18.2, okay? And actually, it's going to be your first 5 days are actually going to be shown at day 3, right? But it is the average over a 5 day period. So my first average is 18.2, right? And then I can compare that 18.2 to the real number for day 3, which is the 11. So when you compare my day 3 actual revenue to the 5 day moving average, you can see that there is a negative 7.2, which basically means that my actual revenue, right, is a little bit below the average. Okay. Going down to day 5, okay, which is on that Friday, we can see that our revenue was $28, okay, and our 5 term average over that week is $19.4. Here you can see that our actual revenue is actually above the average. All right, so that's basically how we do a 5 term moving average. It's just all it is an average over a 5 day period. So now this is what our data looked like before we did the 5 term moving average, and this is what it looks like afterwards. It's the same data. We just basically filtered out all of those steep fluctuations, and now we're basing our number on an average over a 5 term period. Okay. Now, later on in my presentation, right, I talk about regression analysis. Okay, and I give you all some pretty rich detail regarding how to calculate, or rather the calculations behind a regression. So I'm not going to go into detail with that, and I just show you, but I'm going to show you what I have here on my spreadsheet. Okay, so as you can see here, I've set my spreadsheet up so that I can calculate my regression, and I have year 92, year 1 through year 19, which is 1992 through 2010. However, my original data stopped at 2005, so really my data only was about here, okay? And then everything from 2006 to 2010 basically are projected numbers. Okay, as you can see here, this is why I have nothing beneath these numbers, because these are all projections. Okay, and I put up here in this row above my data what these numbers are. So this is my X, my year, right? My year number. My Y is my revenue numbers, okay, in millions, okay. And then I have, of course, the mean minus X minus the mean of X, Y minus the mean of Y. Then I multiply the mean differences. I tell you what I'm doing here. And then I take the mean differences, which is X minus the mean difference of X squared. So basically, I just squared this number, okay? And I use all that to come up with my summarization calculations for my regression. So I have the mean of X, the mean of Y, the square of some of my differences, okay? Uh, the sum of the multiplied differences, okay? And then I calculated my slope and my intercept, okay? And so if you recall, the slope basically is gives you a gauge of the direction that your data are going to trend in. So right now this looks to be a positive slope, so I can pretty much expect a positive influence on, of my independent variable on my dependent variable. And then my intercept, again, alpha, that alpha statistic that I told you all about, is 35.69. And again, what this basically means is if I had no independent variable data, or if all my years were set to zero, if I had 0 years, right, my average output for my dependent variable would be 35.6 million. That's a rough way of explaining what this basically is. But the intercept is really a constant value to kind of give you a gauge of what your dependent variable would look like if you had zero independent variables or you had nothing affecting it, basically. But in real life, we know that's impossible to have zero time or anything. But again, in statistics, we just basically use that as a gauge to help us uh, understand where we're starting from, okay, or compare our numbers to, if you will. Okay, so now I also talked about the exponential regression, right? Revenue regression here with an exponential trend analysis. Um, Now I have my natural numbers here, and these numbers are a bit different. Okay, but I have my natural numbers here, and you can see in this column now I've logged my numbers. Okay, and once I've logged those numbers, the numbers as you can see have gotten much smaller. All right, so now my 2006 through 10 data are now being estimated based on the logarithm of my natural number. Okay, so now what I didn't talk about in my last video was when you get done doing your trend analysis based on an exponential trend, um, you're going to come up with, of course, these log numbers. But log numbers really don't mean anything to officials, right? So now we have to change those log numbers into the natural number. So in order to do that, you just basically take 10, the number 10, and take it to the power of whatever this number is. So when I took 10 to the power of 3.350, that gave me 2,239. I took 10 to the power of 3.389, and it gave me 2,449, etc. So basically, what you can do when you take a number and change it to its exponent, right? To its log using the exponent, you can get that natural logarithm of the number. But you can also change the number back to the natural number by taking whatever that log was and using that as a power over 10. Okay, and that's what officials are really interested in. They want to know what the natural number is, right? If you show a revenue estimate where your numbers are like 3.3 to 3.5, that doesn't mean anything. So you want to change the number back to the natural number.